Hello, this is Jeff Scott of Blackhawk Technical College. I'm going to have two last lectures for the 152-153 Mobile Web Development iOS class for the spring 2015 semester. What I plan on doing today is going over this PDF that I've created for you. It's called SpriteKit Swift Tutorial for Beginners. It's one of the RayWenderlich.com tutorials. Notice it's a little dated, but not too much. I'd say it's about, what, six months old or so? All right, I guess almost 7 months. So as it says, in here you learn to create a simple 2D, two-dimensional iOS game, all right, in this tutorial. And it's been updated, okay? So remember, when we start going through this article is written by developers. So when they say some things like SpriteKit is one of the best ways to make games on OS, Swift is an easy language to get started with, you may or may not agree with that. We've talked about this kind of thing before. There is an original version of this tutorial that was written a while back. I'm not going to go through it. I haven't even looked at it myself. One of the things that's discussed in here is the fact that there's two basic types of gaming engines that you can use, and those are SpriteKit and Unity. So the author kind of compares and contrasts them and talks about which one you should choose. Now I don't want to read this to you, all right? But let's just go over some of the highlights to SpriteKit. It's easier to use. It actually is something that was written by Apple. It's free. Okay, and it's built right into iOS projects. Okay, and it works great, especially if the games that you're creating are fairly simplistic games. Now, on the other hand, you can have Unity. Notice Unity is cross-platform. With SpriteKit, you're basically locked in to using iOS, but with Unity, you can port your games to any platform. Unity, as it says, with their visual screen designer, makes it easy to lay out levels and test the game in real time. All right, where you can't do that nearly as easily with SpriteKit. Unity comes with a built-in asset store. If you remember with our XC assets that basically we're talking about, there's a lot of predefined images that you can use, all right, amongst other things. And it's more powerful. So, as they say here, which one should you use? Well, again, this is the author speaking. So the author says if you're a complete beginner and or you're solely focused on iOS, use SpriteKit. If you're going to be doing something that's cross-platform, use Unity. Well, they've got a whole set of Unity tutorials. I haven't put those out there, all right? But if you're interested, I guess you can take a look at those. So what I'm going to do is walk you through what they've done in this particular example. And then we're going to go through it as a class. But when we go through it as a class, this will be tomorrow, Tuesday, the 28th of April. And as we go through it, we've got 2 hours, and it's a lot to go through in 2 hours. Okay? So when we come in and we start up our new project for one of the first times at least, the first time I've done it, is we're going to be coming in here instead of choosing master detail or page or single view, which you've been doing most of the time, or tab, which you might have done once or twice, we're going to choose game. All right, and they tell you for the product name to call it SpriteKit Simple Game, Swift for the language, and iPhone for the device. So in other words, it should look like this. Now, is it that important that, you know, as far as what you name it? No, that's their organization name. All right, the language, yes. The game technology, yes. The device, well, they set it up for this. And you'll see a couple things about that in just a second. Again, the plan today is to walk you through this PDF. And if I have time tomorrow, what I'd like to do is go over the actual code with you. But I don't know how much time I'm going to have. So, so it says save it, click create, and select iPhone 6 in your simulator and run it. And you'll get a splash screen, and it'll come up and it'll say hello world in this grayish, you know, in the simulator here. And as the author says, SpriteKit is organized into a concept of scenes. Notice scenes are like screens for a game. As it says, you might have a scene for the main gameplay, another one that maps between levels, so as you go from one stage to another. You might have another scene for scoring at the end, depending on how you write this. Alright, it says if you take a look at the project, you'll see that the template has already created a scene for you. That's the default game scene. It says open gamescene.swift, and you'll see it contains some code to put the label on the screen and add a rotating excuse me, add a rotating spaceship when you tap on the screen someplace. So in the tutorial, as mentioned, we'll mainly be working with game scene, but as mentioned before we begin, we have to make a few tweaks. One of the things is we want to go back to our main screen, and we want to set it up so that it only runs in landscape. It says first, it's set up to be portrait, but you want landscape. And the reason for that is quite often games are played in a landscape mode. So I think that's at least why the author does it. So they have them come in here and go into your Navigator, and we'll do this as a class. You've seen this before. And what we want to do is the upside down should be unchecked anyway, but we want to uncheck portrait, which was previously checked, which means, again, we can only play this in landscape mode. Second, it says here, delete gamescene.sks and choose move to trash when prompted. As mentioned, this file allows you to lay out sprites and components in a scene visually. But in here, we're going to do it programmatically. Now, you may or may not like the way the author does this, but I'm just going to follow his steps. That's the idea behind it. So we open up GameViewController.swift, and it says replace the contents with what we see here. So let's take a look at some of the stuff. You'll notice we're importing SpriteKit. Our GameViewController is inheriting from UIViewController. All right, we're coming in here and we're setting up a bunch of different things for the game. All right, and notice prefer status bar hidden. We're going to return true. Okay. So as mentioned, GameViewController is a normal UI view controller, except that its root view is an SK view, SK for SpriteKit. All right. It says here we've implemented the viewDidLoad to create a new instance of a game scene right there on startup. Now, everyone in the class is going to get a hard copy of this PDF, so I don't have to keep moving back and forth on it with the screen. So, all right, it says that's it for the initial setup. So let's add something on the screen. First, as mentioned, download the resources for the project and drag them into your Xcode project. Make sure that your copy, open up gamescenes.swift, gamescene.swift, and replace the contents with the following. Now, I'm going to leave this code up here, and then on the bottom of page 7, they explain what each one of these steps mean. And a lot of it's going to sound like, well, Jeff, you're just kind of reading it. I am. I've read this thing a couple times. I've gone through it and tried to put in the code, basically, and had pretty good success. Okay? So, the first thing that we're doing right here is we're declaring a private constant for the player. In this case, the player is going to represent a ninja. All right, and that's an example of a sprite. To create a sprite, as mentioned there, we simply pass the name of the image that we're going to use, and that's the image right there. Second, pretty simple. We set the background color to white. Third, we come in here and we're positioning the sprite. Now, this is where it gets a little hinky, for lack of better words. And what I mean by that is, do you have to know math? Well, you have to have at least an understanding of math because we're positioning different things on the screen. So yes, you do. So we're positioning the sprite to be 10% across vertically and centered horizontally as far as its first position on the screen. Then in the fourth step right there, to make the sprite appear on the scene, you must add it as a child of the scene. Then we build and run at that time, And when we do, it doesn't look too grand or glorious, but as you see on page 8, that's then what we have. That's our ninja. So, as mentioned here, all right. Next, you want to add some monsters onto the scene for the ninja to combat. To make things more interesting, we want the monsters to move to make it more of a challenge. So they create the monsters slightly off the screen to the right, set up the action by telling them to move to the left. And that's what we're starting to do in here. So the author says, come in and add the following methods to our GameScene.swift file. Now he's put some stuff in here. Again, creating a sprite again, as we saw earlier, but this is the monster. Determine where we want to spawn the monster from. So where do we want it to appear? How often do we want it to come, etc. So we position it again, slightly off screen, along the right edge. All right, then we add a monster to the scene, as you can see right here. Oops. Determine the speed of the monster, right here, and then create the actions. Now, that was just me doing a lot of the reading that the author has put in here. But I do want to mention a couple of things that the author says here. So as it says, the first thing we're doing here is some simple calculations to determine where to create the object, where to position it, and how to add it. The same kind of thing we did before. The new element, as mentioned here on the middle of page 9, is adding the actions. All right? So SpriteKit comes with some built-in actions, and the 3 that we're using right here are the 3 shown right in the middle here of page 9. See if I can move this up just a tad. All right. First, as mentioned, we have SK action move to. Notice you use this action to direct the object to move off screen to the left. Next, we've got SK action remove from parent. To remove the node from its parent, in other words, delete it from the scene. It says we use this action to remove a monster from the scene when it's no longer visible. And why is that important? Because if the ninja shoots a monster, we want the monster to disappear. If we didn't do that, eventually the screen would be filled up. Especially if we had just one ninja, it would be filled up with these monsters and you couldn't see anything. Third, the sequence allows you to chain together a sequence of actions to be performed in order one way at a time. It says this way you can have the move to action perform first, and once it's complete, perform the remove from parent action. One last thing that we need to do right in here, we need to actually call the method to create the monsters. All right, it says, and to make things fun, let's have the monsters continuously spawn over time. So we add the code that's shown on the bottom of page 9 here to the end of our did move to view. Okay, and you see there's only 3 lines here. I don't want to move it because it's going to go on to the next page. And it says, here you run a sequence of actions to call a block of code and then wait for 1 second. Then you repeat the action, and you're going to basically put that, do the equivalent of tell it to keep doing it. Wait a second and then do it again. Wait a second and then do it again. So, as mentioned, says that's it. Build the project, and now here come your monsters. So there's your monsters. Unfortunately, the graphics that are in here, as you can tell, are pretty amateurish. So our ninja doesn't look that different from our monsters. All right, so we now have a ninja and we have some monsters that are coming across on the screen. So, the author mentions here, and again, I'm on down towards the middle part, bottom middle of page 10. At this point, we want to add some shooting. It says there's many ways we could implement shooting, but for this game, we're going to make it so when the user taps the screen, it shoots a projectile from the player in the direction of the tap. The author says there he wants to use the move to action to implement this to keep it at a beginning level. But in order to do this, you're going to have to do a little bit of math, as you'll see especially on the next page. And the reason you need to do some math is because move to requires that you give a destination for the projectile. You can't just use the touch point because it represents just the direction to shoot in. In other words, you want to be able to aim at the monster, not just have it shoot in the same spot all the time. So they show this pictorially here on the top of page 11. And the author says, as you can see, you have a small triangle created by the X and Y offset from the origin point to the touch point. You just need to make the a big triangle with the same ratio, and you know you want one of the endpoints to be off screen. All right. So the author mentions here, whoops, I don't want to do that, so let's cancel. So the author says to run these calculations, it helps if you have some basic math vector routine experience. Well, you probably don't. Mine is limited at best. So it says, however, SpriteKit doesn't have any defaults, so we'll write our own. Luckily, they're very easy to do thanks to the power of Swift overload operating. Now, this is, again, something that's taken right from the C and C+ languages, which means that you can take an operator and make it do things other than what it's supposed to do. And if you look in here, what we're operating, or what we're overloading, are the plus operator, the minus operator, the times operator, and if I go down enough, the divide operator. So it says add these functions to the top of the file before the game scene class. It says these are standard implementations of some vector math functions. If you're confused, check out the vector math explanation. I'll try to remember to add all of these hyperlinks that they have to the information that's in the in-class folder for 428. All right? Okay. Then we come in and it says add a new method to the file. It's shown here on the bottom half of page 12, and then the steps are reviewed on page 13. So that's what I'm going to do right now. So step 1 says one of the cool things about SpriteKit is that it includes a category on UI touch with location node and previous location in node methods. These let you find the coordinate of a touch with the sknode's coordinate system. Here we're using it to find out where the touch is within the site's coordinate system. Step 2. You then create a projectile and place it where the player is to start. It says, note, you don't add it to the scene yet because you have to do some sanity checking first. We only want to let the ninja shoot in a forward direction. Third, subtract the projectile's current position from the touch location to get a vector from the current position to the touch location. In other words, we're trying to set it up, for lack of better words, so that the ninja is able to aim. 4. If the value is less than 0, this means that the player is trying to shoot backwards. This is not allowed, so just return. 5. Otherwise, it's okay. To add the projectile to the scene. 6. Oops. Convert the offset into a unit vector by calling Normalized. This makes it easy to make a vector with a fixed length in the same direction because 1 times length equals length. All right. 7. Multiply the unit vector in the direction you want to shoot by 1,000 because that should be long enough to get past the edge of the screen. 8. Add the shoot amount to the current position to get where it should end up on the screen. Finally, step 9. Create move to and remove from parent actions. Build and run, and the ninja should be able to shoot at the incoming monsters. And that's, I'm not even going to go over page 13 because those are the steps that I just mentioned to you. All right? All right. Gets a little heavy here starting on page 14. It says, so now you have these monsters flying everywhere, but what your ninja really wants to do is lay some smackdown. So let's add in some code to detect when projectiles intersect with the targets. One nice thing about SpriteKit is it comes with a physics engine built in. And those are great for collision and detection purposes. It says, let's set up the game to use SpriteKit's physics engine to determine when monsters and projectiles collide. So in other words, when the ninja has shot a projectile at the monster and hit it. Okay? So it says at a high level, this is what we're going to do, and it shows you about 4 steps right in the middle of page 14 here. Set up the physics world, which is a simulation space for running physics calculations. Second, create physics bodies for each sprite. It says in SpriteKit you can associate a shape to each sprite for collision detection purposes and set properties. That's what's known as the physics body. Third, set a category for each type of sprite. Fourth, set a contact delegate. It says you can set a contact delegate to be notified when the 2 physics bodies collide. Then we'll write some code to examine the categories of the objects, and if they're the monster and the projectile, we'll make it go away. All right. So next, starting on the bottom, there's just a little bit of code on the bottom here, page 14. It says let's put this into action. It says this is setting up the constants for the physics categories that we're going to need in just a little bit. And the author mentions on the top of page 15, says you may be wondering what the fancy syntax is here. Note that the sprite category is just a single 32-bit integer and acts as a bit mask. This is a fancy way of saying that each of these 32-bit integers represents a single category. All right, and we're going to set the first bit to indicate a monster, the next bit to represent a projectile, etc. Then, as shown here towards the middle of page 15, the author says, next, Mark Game Scene is implementing the SK Physics Contact Delegate Protocol, right there. Then inside of our did move to, we have to add a couple lines after we add the player to the scene. As it says, this sets up the physics world to have no gravity. And it sets the scene as the delegate to be notified when we have one of our collisions. Finally, inside of our add monster method, we've got to add the code that's shown right here as I'm swirling the mouse around. So they mention line by line what's going on here on the bottom, on the bottom of the page. So the first line is mentioned creates a physics body for the site. In our case, the body is defined as a rectangle of the same size as the sprite. Second, it sets the sprite to be dynamic, meaning that the physics engine will not control the movement of the monster. We're going to control it through the code that's been written. Third, we set the category bit mask to be the monster category defined earlier. Fourth, the contact test bit mask indicates the categories of objects that this object should notify when there's an intersection. We choose the projectiles here. And finally, in step 5, the collision bit mask indicates what categories of object that the physics engine can handle. All right, it says it's okay for them to go right through each other in this game, so we set it equal to 0. Next, as we move up to page 16 here, it says, next, add some code to the touches ended right after the line setting the projectile's position. All right, so we put this in here. It says, as a test, see if you can understand each line here. If not, refer back to the points explained above. Okay? It says there's 2 differences in here. You're using a circle-shaped body instead of a rectangle body. Since the projectile is a nice circle, it makes for the better match. And second, you also set uses precise collision detection to true. Right there. It says this is important to set for fast-moving bodies like projectiles. Otherwise, there's no chance that 2 fast-moving bodies can pass through each other without a collision being detected. The next thing we want to do in here, again, I'm halfway down on page 16. The author says, add a method that will be called when the projectile collides with the monster. It says, note that nothing calls this automatically. We're going to call it later. All you do here is remove the projectile and monster from the scene when they collide, which is, when you think about it, that's really what we'd want to do. Now, as mentioned here on the top of page 17, trying to on the top of page 17, cancel. Oh, this is a little bit different than that. Okay. Oh, boy. Okay, what are the differences? Yeah, I'm right here. Like I said, I'm working off a hard copy that's set up differently. I made another copy of it since then, so. All right. Now they say here it's time to implement the contact delegate method. So what we're supposed to do is add the following new method to the file. This did begin contact. That's right here. And you can see some of the code here. And as mentioned right here, the majority of the code that you see right here, it says this method passes you the two bodies that collide, but it does not guarantee that they are passed in any particular order. So this bit of code arranges them so that they're sorted by their category bit masks, so we can make the assumptions that we talked about earlier. Then secondly, the stuff that's in here, it checks to see if the two bodies that collide are the projectile and the monster, and if so, it calls the method we wrote earlier to basically remove the monster. All right, it says give it a build and run, and now your projectiles intersect targets and they should disappear. So when you hit it, it should go away. Like I said, I shouldn't be going off of the hard copy that I have here. I've got to print out another copy of this hard copy. All right. So for finishing touches, it says you're pretty close to having a workable, though extremely simple game. Just need to add some effects, sound effects, and music, and some simple game logic. SpriteKit does not come with an audio engine, but the good news is it does come with a simple way to play various actions and sounds. So we start to do that on page 18. It says, to do this, add the following code to the top of gamescene.swift. It says this is some AVF foundation code to play the music endlessly. To try it out, as mentioned down toward the bottom of page 18, the author says, add this line to the beginning of the did move. All right. And it says, as for the sound effect, add this line to the touch's end. It says you can now play a sound effect with one line. It says, now let's create a new scene that will serve as the you win or you lose indicator. Create a new file with the iOS Swift file template. Name the file GameOver Scene and click Create. Then replace the GameOver Scene.swift, which you'll get by default, with what's shown here on page 19 and is explained on the top of page 20. So let me get as much of this in as I can here, and then we'll go over it. All right, step 1 right here, pretty simple, set the background color to white. Step 2, based on the 1 parameter, set the message either to you won or you lose. All right, could have changed you lost, but what, it doesn't matter. Step 3, this is how you display a label of text to the screen with a SpriteKit. Just choose your font and add a couple parameters. So hopefully that makes some sense, and then we just add it. Step 4, this sets up and runs the sequence of the 2 actions. The author says, I'm including them all inline here to show you how handy it is. First, it waits for 3 seconds, Then it uses the run block action to add some arbitrary code. Step 5. This is how you transition into a new scene in SpriteKit. First, you pick from a variety of different animated transitions. You choose a flip transition here that takes half a second, then create the scene to display. Finally, step 6 says if you override an initializer on a scene, you must implement the required init initializer as well. So, the author says halfway down here on page 20, so far so good. Now you just need to set up your main scene to load the GameOver Scene when appropriate. So we go back to the GameScene.Swift, and inside of the add monster, we replace the last line that runs with what you see here. This creates the lose action that displays the GameOver Scene when a monster goes off screen. And the author mentions here on the near the bottom of page 20, says, why is lose action first? And as mentioned there, as soon as you remove a sprite from its parent, it's no longer in the scene hierarchy, so no more actions will take place from that point on. So you don't want to remove the sprite from the scene until you've transitioned to the lose scene. Actually, you don't even need to call the action move done method anymore since you're transitioning to a new scene, but the author left it there anyway. Finally, on the last page, it says you really should handle the win case also. Add a new property to the top of the game scene, monsters destroyed, and as it says, add this to the bottom of the projectile. Give it a run. So it says there basically if the monsters destroyed are greater than 30, it's going to come back up and tell you that you won, as shown here. Right there. So, where to go from here? You've got the code. And again, we'll take a look at it. Notice the author has got his own book there, iOS Games by Tutorials, which has got a lot more in it. But this is for lack of better words, this is just kind of a simplistic little start. It may not seem that simple, but compared to a lot of the other stuff that's available in games, it is pretty simple. Now, I don't know if I have this here or not, so let me check. It would be here. Just so you see this is what I've got out there. Oh no, this is just, let's see, yeah, this is what I thought it was. Okay, good. So you've got a bunch of examples out here, some tutorials, Space Invaders Part 1, 2, and 3 using SpriteKit. The SpriteKit tutorial for beginners, which is what we just went over. Trigonometry for games. And WatchKit introduction for building games. A couple things I wanted to mention quickly. This Swift games, it should be Swift, not Swing Games. So it should be Swift Games, URL.text. There's a couple things that you might be interested in. There are a couple of online YouTube videos. All right, I watched a few things here, but not really a whole heck of a lot, to be honest with you. And then finally, I thought this was interesting. No, I don't. Let's see. Let's just do this for now. This tutorials docx, hopefully that'll come up good. And I found this online. And literally, there are probably somewhere between 20 and 50 already done tutorials. That some are SpriteKit, some are Unity, but they're all game tutorials. All right, hopefully if you have an interest in that, you'll take a look at it. That's all I have for right now. Again, I'm going to try to come back tomorrow and go over the code in a little bit more detail. Talk to you then.